So this is actually technically, I should have had this as C. Okay. So graphically, we've already figured this out, that the limit as x goes to a of c. C is a constant function. So if I have, here's my x and y axis, and I have something that looks like this, like say y equals 2, do you understand that the limit is always whatever that constant function is, right? Okay, so then if we have, if this is my x and this is my y, and I have that y equals x line, that's that 45-degree line. Do you understand that no matter what your x is, it's the same as your y? So whatever your x is, your height's the same. Make sense? Okay, so that's something you can just memorize, or you can figure out by just thinking about it for 2 seconds. The other thing that you probably figured out, that you find a limit if you can just directly substitute this whatever this number is directly into the function, and then you get the limit. So let's try it. So there's 3 possibilities that happen when you actually sub it in. It works. So 5 goes in there. You get 5 squared minus 4 over 5 minus 2. So you get, what, 21 over 3, which gives you 7. So that means the limit's 7. So you should always try to plug it in and see if you get something, okay? So there's another scenario. You plug it in and you get 0 over 0. So what did you remember from grade 12 when you get 0 over 0? That represents, at that limit, there's a hole. There's a hole in the graph at that x value. You want to find the location of the hole. The y value at the hole is your limit. So in grade 12, the hole, you figured out to know where to draw the hole. But for the limit, it doesn't matter if there's a hole there. It's the intended height, right? It doesn't matter if there's an actual function value there. Okay, so if I substitute 2 in here, do you see I get 4 squared minus 4 over 2 minus 2? I get 0 over 0. So if you get 0 over 0, that's your red flag. Oh, I got to do something else to it. It doesn't mean I'm done, right? So we're going to factor. How do you factor the top? And again, if we haven't actually evaluated the limits, you have to write the limit again, okay? So this is x minus 2, x plus 2 over x minus 2. This kind of rings a bell of when we did rational functions in grade 12. Remember, those cancel, and you're supposed to write x cannot equal 2. Well, in limits, we don't have to do that because we don't care about that part of it. We want to know what the actual limit is. Then the 2 goes in here. We get 2 plus 2 is 4. And so then that means you know that the hole was at 2, 4, the coordinate. But again, we don't care about that coordinate. We care about the limit. You have to write 2. Okay. So next one, we substitute -1 in there. I get -1 squared, which is 1. 1 plus 1 is 2. 2 minus 2 is 0 on top. -1 plus 1 is 0 on the bottom. So I get 0 to 0. You don't have to show that, but you should be subbing it in to check first, because sometimes you actually get something, right? So now we're going to factor. And this is x minus 2, x plus 1 over x plus 1. Those cancel. And graphically, does everybody understand what this looks like? What is it? It's a line with a hole in it, right? So now I'm going to plug -1 in. I get -1 subtract 2 is -3. Yeah, of course I did. Okay, so now you plug this in, you get 0 over 0. Let's just check. -2 goes in, I get 0 at the top. -2 goes in there, I get √2. Subtract √2, I get 0 at the bottom. So I get 0 over 0 again. Try to factor that. Can't. Okay? So now this is the third possibility, is conjugate. Do you remember what conjugate is?
What was that for example?
Yeah. What's the conjugate of this?
You multiply by root x plus 4 plus root 2.
Yes. Okay, do you guys remember when you were doing trig identities, you were proving trig identities, when you did the conjugate, you only multiplied the one that you're trying to get rid of, the one with the conjugate. Don't multiply the other one out. Same thing goes here, okay? So, again, the limit as x goes to -2, we're not going to multiply that in. It's going to get messy, okay?
Yeah.
So it's x plus 2 times root of x plus 4 plus √2 all over, what do we get at the bottom? x plus 4 minus 2, which then that simplifies to be
How did you just get that?
The conjugate sound.
you have to FOIL the bottom.
What did you get, like, how did you get x plus 4?
Does everybody see this is the reason I didn't multiply the x plus 2 in? Because this is going to happen. It's going to happen, okay? So now I'm going to substitute this in. I get root 2 plus root 2, which is 2 root 2. Next one, I sub in 3 here. I get 9 plus 7 is 16. Root of 16 is 4. 4 minus 4 is 0 on the top. I put 3 in here. I get 9 times 4 is 36. 3 goes in there, 15. 36 minus 15 minus 21 is 0 on the bottom. So 0 over 0, there's a hole. What are we going to do the conjugate here? 4 plus root x squared plus 7 over 4 plus root x squared plus 7. Remember, we're only going to multiply the one that has the conjugate. The rest I'm going to leave alone. So then 4 times 4 is 16 minus, the outer and the inner will cancel. And watch this. This is a minus the whole thing, x squared plus 7, right? Now, I'm going to actually try to factor that quadratic there. Maybe I'll wait. Do you understand why I would wait? Because, yeah, something is going to cancel on the top, so then that will kind of lead me how I'm going to factor. And this could be anything there. So I'm just going to leave it as x squared minus 5x minus 21 times 4 plus root of x squared plus 7. Okay, so what's 16 subtract x squared subtract 7? Yeah. 16 minus, sorry, can we not just do the math? 9 minus x squared?
Oh, yeah, I guess.
Yes? Now, does everybody know what that factors to be?
Yes, 3 minus x.
Yeah, so that means I probably have something in there. Yep. So there's probably going to be an x and a 3 in there, right? Because I know on top is going to be an x. 4x minus 7. No, this is a minus. This is a plus. Yes? Is that what you got? Okay, I'm going to... Okay, if you want, just to save another writing, I'm going to write, I'm going to write 3 minus x times 3 plus x.
So are you going to pull?
Okay, do you remember the -1 trick?
Yeah.
X minus 3 will cancel with 3 minus x if there's a -1 in there, right? It's like factoring on the -1 out of x, 3 minus x. If I take 3 minus x and factor out a -1, do you see I get x minus 3? So that's why I call the -1 trick, is because if I see the same but they're opposite signs, I can cancel, just stick a -1 in there, okay? So now I'm actually, those are canceled. I'm going to plug her in. I get 3 plus 3 times minus 1 over, on the bottom I get, what, 12 plus 7, and 4 plus root 16, yes, which is 4. So what do I get on top? I get -6 over 19 times 8. Why did I not multiply the 8 out? Does everybody see why I didn't multiply the 19 with the 8 yet? So I can cancel. It's way easier. So 6 eighths reduced to 3/4, right? And then I get -3 over, what's 19 times 4? 76. By the way, AP College Board says you could actually leave your answer like that. Because don't you want to actually see if your answer is right? Because the answer in the back of the book is going to have that, right? So, okay, square root of 0. What is the square root of 0? It's 0. You think so, I'm asking you this because it's hard. But you're absolutely correct. The square root of 0 is 0. However, if it is a plug and chug for limits, okay, so if it's a limit, you can't say plug it in, get the square root of 0, and say it's 0. There's more you have to investigate because the path does not actually equal that. So, because we cannot, the reason why we can't say the limit actually of 0, as x goes to 0 of the square root of x is 0 is because we have to look at the path. So if you think about this for a second, y equals the square root of x, what does that graph look like? Yeah, like that. So do you see if x goes to 0, there's not a left side of the limit, right? So what happens if the left side of the limit doesn't equal the right side of the limit?
Then there's no limit.
The limit does not exist. Right? Okay. And so we cannot compute the square root of negative numbers, and that's the reason why there's nothing on that side. Okay, so I substitute negative 2 into this limit. I get negative 2 plus 2, the square root of 0. I cannot officially say 0. Okay? This has to be in your back pocket, right? You have to remember, if you get the square root of 0, you have to actually investigate further. So what you have to do is you need to put them in left and right side. Once I do it from the right, does everybody understand from this point now that negative 2 plus actually means?
2.011.
No, you're wrong.
No, it's negative.
Oh, you're right.
Negative 1.9, negative 1.99. Okay, so if I plug in negative 1.9 in here and I add 2 to it, will I get? You get positive. So I actually get 0 out of that, which makes sense because what does this look like graphically? Do you remember what y equals the square root of x plus 2 is?
Yeah, just shifted left.
Shifted left to bam.
Yeah.
So does that make sense? When the limit comes from the right of negative 2, it equals 0. Okay, so now if I go the limit as x goes to minus 2 minus, what do I get there? Well, what does negative 2 minus mean? Yeah, or even negative 2.1, right? You don't have to get so crazy there. So now if I put this in here, you get the square root of negative numbers, which you can't, so that means D and E. These don't match, so then what do I conclude? D and E. So if this is multiple choice, easy, D and E. If it's not, you need to justify it by showing the left side limit doesn't equal the right side limit. So the key here is if you investigate further and you get square root of positive numbers, that means it equals 0. If you investigate further and you get the square root of negative numbers, that means you should be saying does not exist. Okay? So then if I put x goes to 7 from the left, what kind of numbers am I plugging in there? 6.9. 6.9.
So it exists.
So it exists and it equals 0. Uh-oh. Do you understand why it's 0 and does not exist? Okay, how about this one? X goes to 7 plus. What's a number that's 7 plus?
8. It's a little bit more.
Don't, okay, so Alexandra said 8. I don't think I would go as far as going that far. 7.1 is probably as far as you should go. So if you go too far, you might get into another part of the graph that something goofy is going on. You have to get close enough, right? So 7.1, 7 minus 7.1 does not exist, right? Okay, how about this one? 6 goes in there, we get the square root of 0. What are we supposed to do?
Cases, so D and E.
Yeah, we're going to do 2 cases. Say it says justify, okay? So the limit as x goes to 6 plus, what do we get there? So we get 0. The limit as x goes to 6 minus, we get 5.9 minus 6, so we get negative number, so it does not exist. Therefore, the limit as x goes to 6 of the square root of x minus 6 does not exist. I'm justifying it, right? If it's a multiple choice, of course, you would pick that. A lot of the limits, they'll have automatically the D answer does not exist, just to throw it in there. Okay, so if I plug in -2, I get the square root of 0. Do you remember how we did quadratic inequalities? Because we're trying to find it where it's positive, right? Remember the sign diagram thing? And you tried to see. Okay, so if I were to factor this, because there's already a left-sided limit here. What is this factor to be? X minus 9, x plus 2. Okay, remember when we did the sign diagrams, we didn't really care what the number was, we're just looking for the sign. And then we wanted to know if it's a positive times a positive or a negative times a positive to see if it's overall positive or negative. Okay, so what does -2 minus mean again? -2.1. It's on the left of -2. Like think of the number line, it's -2.1. So don't actually figure out the number, figure out the sign. So if -2.1 goes in here, what do we get there? A negative. If -2.1 goes in there, what do we get? A negative. And what's a negative times a negative? A positive. And the square root of a positive number is 0, right? Because it's the one-sided limit. Yes?